In this section, we'll be describing how to set up a mixed signal oscilloscope to collect analog and digital data from a DAC under test. In fact, the two analog channels, channel A and B, will be monitoring two output analog channels from the DAC, and two digital channels will be used to monitor the I2C bus controlling the DAC. So first thing, to set up the two analog channels. So channel A, I'm going to set up to plus or minus 2 volts, and similarly on channel B, plus or minus 2 volts. In fact, the DAC is already sitting at an output level of just below 2 volts. So here we see the two channels on. So if I just turn off channel A, here we see channel B also at just below 2 volts. So here we have the two channels set up. So I'll just change the time base factor to 500 microseconds per division, and I'll set the record length to 50 kilosamples. So that's the two analog channels set up, and this is a conventional menu system for PicoScopes, but this particular instrument has a additional icon for setting up the digital channel. So here we see the 16 available digital inputs. So the first thing we can set up is the threshold for any trigger condition, and these are in two 8-bit blocks. So I'm going to set up TTL, because the I2C bus in this particular case is going to be TTL logic with a trigger level of 1.5 volts. So then we can select particular channels and put them into the group display, and these can be just individually dragged, or we can select a whole range of channels and drop them into the group display. We can then group them into a group, so we can create a group here, G1, and then again drag the individual channels into the group, or we can highlight again the whole group of channels and drop them into the group display. So here we now have all 8 channels into the particular group, and we can minimize the display. And we can rename the group, so we can give it a meaningful name, so it could be, for example, a data bus. And in fact, we can also rename the individual channels. So this might have a special input channel, for example. So meaningful names can be given to the group and to the individual channels. In this particular example, I'm only going to be using 2 channels, so I'm going to remove those particular channels. I'm going to be using just D0 and D1. These are going to be the two control lines for the I2C bus, the data and control bus. So D1 is going to be the data bus, so I'm going to call that data. And the D0 channel is in fact going to be the clock line. So they are the two channels for my particular decode, and I'm going to apply this setup. So now we see we have 2 windows. We've got the analog window and the digital window containing the clock and data lines. The third window I'm going to open now is the decode window. So under the tools menu, you can select serial decoding, and these are the channels that the data can be collected on. It can come in on the analog channels or the digital channels. The advantage of the analog channels is that you can select individual thresholds on each particular line. So these are the buses available, and we can select any one of those buses and then declare individual thresholds. But I'm going to be using the D1 channel here for my I2C data bus, and here we see the setup is allocated by default the clock into channel A, but I'm going to move that now to the digital channel D0, and here again we see the threshold was previously set to the TTL line. So the display will appear in view. That's going to be in the analog display, and I'm also going to open a third window for the decoded data. So I will apply that change. Just under the settings, we can select 7 or 8-bit data on this particular bus. So I'll say OK on the setup. So now we have a third window opened where the decoded data will appear when the instrument triggers and acquires data. So the final thing to set up is the trigger. Trigger condition at present is none. Typically these acquisitions would probably be a single shot when you acquire a burst of data, and the actual trigger conditions under the icons here, so these are the analog conditions, edge triggers, advanced and Windows and pulse width triggers, and these are the two new icons for the digital data. So under logic we can see the A and B channels, and under digital now we can set up, say, a whole digital word. So for example, we might want to trigger on word A6, and here we see the representation for an A6 trigger. In this particular case I'm going to put it back to binary and just select one channel, so I'm going to be selecting the channel D0 going high. And similarly, if we look in the digital channel here, we can see the trigger that's been set. So again, you can set it in this window similarly, and then we can select D0 going high. So either menu can be used. So I'll just close that window. So now we have the trigger condition set up. So at this point the windows are declared and the trigger condition, and typically we would save this as a setup condition. So I'm going to put it into my menu system. So I'm going to put it under my I2C application. So I'm going to be calling it I2 trigger condition and save it. And it says, yes, you sure want to do that. So I've now saved away my trigger condition and my setup, so that can be recalled at any time in the future.